Welcome to this video presentation on the functional groups present in organic molecules. In this video we will identify the functional groups that can be present in organic molecules and describe the suffix that is used to identify the functional groups in the molecules' names. To start off with, what is a functional group? A functional group is the part of the molecule where there is a group of atoms bonded in a particular arrangement. This arrangement is key. It gives the molecule its properties and dictates the type of reactions that it will have, as well as the other properties like solubility and boiling point. Functional groups are identified in the molecule's name by a specific prefix or suffix, so we will look at the examples of these in turn. We'll start off with the hydrocarbons first. We've already seen alkanes in previous videos. Alkanes only contain carbon-carbon single bonds and carbon-hydrogen bonds, so don't have functional groups present in them. Hydrocarbons with a double bond between carbon atoms, however, are called alkenes, and this is seen using a double line between carbons. Alkenes are identified with the suffix "-ene in their name. So here's an example of an alkene, pent-2-ene, with the alkene functional group being present here. Hydrocarbons with a triple bond between carbon atoms are called alkynes, and they're drawn with 3 lines between carbon atoms. Alkynes are identified with the suffix "-ine in their name. And this example is propyne, with the triple bond functional group being present here. A hydrocarbon with a halogen group attached to it are called haloalkanes. Haloalkanes are identified using the prefix chloro or bromo to identify the presence of the halogen branch on the molecule. This molecule is chloromethane, as it has 1 chlorine on the methane molecule. This haloalkane is dichloromethane, as there are 2 chlorines on the methane molecule. This molecule is 1-bromo-propane, as there is 1 bromine atom attached to the first carbon of the propane molecule. And there is an isomer of this called 2-bromo-propane, where the bromine is attached to the second carbon. All 4 of these molecules are haloalkanes. The amino group is an NH2 group with a nitrogen and 2 hydrogens. Molecules with this group are called amines. Amines are identified with the prefix amino in their name. This molecule is aminomethane. It has an NH2 group attached to the methane carbon. Likewise, this molecule is aminoethane with the amino group attached to an ethane hydrocarbon. This molecule is 1-aminopropane, with the amino group attached to the first carbon on the propane molecule. And there is of course an isomer of this molecule, which is 2-aminopropane, where the amino group now can be found on the second carbon. So these 4 molecules are examples of amines. The hydroxy group is an OH group with an oxygen bonded to a hydrogen. Molecules containing this group are called alcohols. Alcohols are identified with the suffix -al in their name. So the first alcohol is methanol, with a hydroxy group attached to a methane molecule. Likewise, attaching a hydroxy group to an ethane molecule gives us ethanol. Attaching a hydroxy group to a propane molecule gives us propan-1-ol. The 1 of course shows that the hydroxy group is attached to the first carbon. Likewise, there is an isomer of this molecule, which is propan-2-ol, where the hydroxy group is attached to the second carbon. Both of these molecules require the position of the hydroxy group to be indicated with a number in their name, as there are 2 possible isomers. The next group we'll consider is the carbonyl group. This is common in many types of functional groups, and we'll look at each one of these in turn. Firstly, a carbonyl group on the end of a carbon chain creates an aldehyde. Aldehydes are identified using the suffix -al. So this molecule is propanal, which is an aldehyde of propane. Notice that the carbonyl group is on the end of the molecule with a hydrogen. If the carbonyl group is in the middle of a carbon chain, it creates another functional group called a ketone. Ketones are identified with the suffix -one. This molecule is propanone. Here the carbonyl carbon is on the middle of the carbon chain. This is a 3-carbon chain molecule, so this will be propanone. It is commonly called acetone and found in nail polish remover. The carbonyl group can also be combined with other groups, and there are a variety of these. Molecules with a hydroxy end carbonyl group are called carboxylic acids. Carboxylic acids are named with the suffix -oic acid. This molecule is propanoic acid as it has 3 carbons with a carboxylic acid group on the end. Likewise, this molecule is ethanoic acid as there are 2 carbons with the carboxylic acid group on the end. Molecules with an amino group and a carbonyl group together are called amides. Amides are named with the suffix amide. So this molecule, which is based on a 3-carbon chain, is propanamide with an amide group on the end. With a 2-carbon molecule, this would be ethanamide. Molecules with a chlorine and a carbonyl group are acid chlorides. Acid chlorides are named with the suffix oil chloride. So with a 3-carbon molecule, this would be propanoyl chloride. And with a 2-carbon chain, this would be ethanoyl chloride. Lastly, an ester. An ester is a molecule which has 2 hydrocarbon sides to it. It is based on a carboxylic acid molecule. We won't consider naming of esters at this point, as they are formed when 2 functional groups are combined and their name reflects that. So we'll just identify the ester functional group at this stage and leave the naming of them to later videos. So that covers all our functional groups. You'll have a table of functional groups in your notes that you can refer to when doing activities like this. You will need to be able to identify different functional groups present in molecules. And of course, as you can see in these examples, molecules contain more than one functional group. So what we will practice here is circling and identifying the functional groups that are present. So I'll do that right now, and you can watch as I circle and name each one, so you can practice the skill on your activity sheets. And to finish, I have covered all the functional groups in this video for level 2 and for level 3, so it's important to note that level 2 students only need to be able to identify alkenes, alkynes, haloalkanes, amines, alcohols and carboxylic acid functional groups. The level 3 students will need to identify all the level 2 groups plus aldehydes, ketones, amide, acid chloride and ester. So that is important to note if you're a Year 12 student, which groups you need to focus your learning on.